To calculate the storage volume for your pond model, you will need a water level boundary to define the precise limit for the pond volume. For this course, the storage volume needs to be calculated for the freeboard elevation of the pond. Using the elevation editor, you can verify the berm elevation for your pond model, which for this pond design is 1 foot higher than the freeboard elevation. Knowing this, the water boundary needs to be extracted at elevation 1441. Leveraging the surface contours from the pond model, you can label the contours to clearly determine which intermediate contour coincides with the freeboard elevation. Strike a line across the contours to add the labels. Then zoom into a pond to identify the 1441 contours. To use the contour in your pond storage calculation, it needs to be extracted from the surface as a polyline. Select the surface object, then from the contextual menu, select Extract from Surface Tools. Select Extract Object. In the Extract dialog, select only the minor contours, then choose Select from the drawing. Use the Pick in Command button to select the 1441 contour line from the drawing. When you're all set, click OK. To confirm that the polyline was extracted, pick the contour line in the drawing. The polyline should be selected separately from the pond surface. Now that you have the water level elevation boundary, you can perform a bounded volume calculation. This tool is executed from the command line. Type report into the command line to filter the tool list and then select report surface bounded volume. This tool allows you to compare a surface into datum elevation. Following the command line prompts, pick the pond surface from the drawing. When prompted to select the boundary, type D or click the datum options in the command line. Enter the freeboard elevation for your pond into the datum elevation prompt and press enter. When prompted for boundary this time, pick the extracted polygon from the drawing. The pond storage result will be displayed in the command line. The cut volume, displayed in cubic yards, is the calculated storage for the pond. To learn what the storage is in a different volume unit, use the quick calculator from the Analyze tab, Inquiry panel. In the quick calculator under unit conversion, set the units types to volume. Then choose the convert from and convert to units. For this pond design, the minimum storage requirements is 118,000 cubic feet. As you can see from the current result, the pond is undersized. The reason the pond model is undersized for this project is due to the pond depth. In the preliminary calculation, which was performed in grading optimization, and the depth was 6 feet, measured from the freeboard elevation. In the design model, the pond depth was measured from the top of bore. To increase the pond depth, you can simply increase the vertical deflection of the inner berm link. Using the subassembly properties, added a vertical deflection for the link width and off slope subassembly. On the parameters tab, add 1 foot to the pond depth and click OK to save your changes. Editing the berm subassembly will require the pond model corridor to be rebuilt. In the Prospector tool space, rebuild the dry pond corridor. Rebuild the pond corridor will also update the pond surface. With the corridor updates finished, perform another volume calculation. Type report into the command line and select bounded volume tool. Following the command prompts, select the pond surface, set the datum elevation to match the freeboard elevation, then select the extracted boundary from the pond model. Notice the volume results have changed and the quantity is considerably larger. To validate the point storage in the cubic feet, use the quick calculator once again. Enter the new storage volume in the calculator to learn the pond's capacity. As you can see from the unit conversion, the current pond capacity meets the 180,000 cubic foot requirement. Now that your pond model is sufficiently sized, you can validate the earthwork volumes.